Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Today we'll start the new chapter, which is about a comparison of traditional, the waterfall approach, and agile software development approaches. So we'll have a critical analysis of the conventional or waterfall development approach. Then we will see what is agile software development, and we'll discuss two of the many techniques in agile software development. We'll just discuss two of them: Scrum and extreme programming. Waterfall, or the traditional development approach, we have discussed in System Analysis and Design 1 and 2 about System Development Life Cycle, what we call SDLC, System Development Life Cycle. We talked about all the phases in analysis and design, and the important thing in waterfall approach is, as the name implies, waterfall. In waterfall, the water always goes from top to bottom. It never goes up, right? So similarly, in waterfall development approach, every phase is completely done before moving to the next phase. So we have complete requirements, we develop a complete design, we have complete implementation, complete testing and support. So the idea is every phase is completely done before starting the next phase. Well, it's a very efficient way of carrying out project, but there is a big if. If everything is designed at the beginning based on complete and final set of requirements, in the coding phase everything is implemented based on complete and error-free design. So if you can manage, first of all, the requirements, if you are sure that you have complete set of requirements and you can develop a complete design and then you can do complete implementation just in one go, it is a very efficient technique. The problem in the waterfall development approach is that the changes become more and more expensive the later they are done. Okay? If the changes are done in the earlier phases, they are cheap. But let's say you have gathered requirements and after that you made design, then you wrote the code. And now when you perform testing, you find out a problem in the requirement phase. So now if you have to fix a requirement, you will have to go back again to design. So you have a problem in the requirement, you make this change, then you have to revise the design, you have to revise the code, and then you have to repeat all the testing process. So the later the changes are found, the more expensive they are to fix, because the philosophy of waterfall development approach is to take everything as complete set. And if there is one thing missing in one phase, you'll have to completely redo that phase and all the phases in the future, the next phases, the subsequent phases, right? So we have to make sure that everything can be completely done just in one go. Another advantage of waterfall development approach is a very good set of documentation. If you recall, in SAD 1 and SAD 2, throughout the courses, we have been talking about repository. So everything is documented properly. Whatever we do, it is documented, it is discussed with the shareholders, there's an approval process. So a very good documentation is produced, and a good documentation is essential when we go for supporting the system. In system support phase, a very good documentation is very important. It will make your life easier as compared to if the documentation is not done properly. Another advantage in waterfall approach is that the test teams are different from the development teams. So when the code is handed over to them, they will try to find as many errors as possible, and the quality of the software will ultimately be high. The disadvantage of waterfall approach is that it is almost impossible to carry out larger projects or the project with some level of innovation without change. So if you have a small project, let's say we talk about your graduation project, it's a small project and mostly the scope is locked, it is fixed in the first or second milestone. We do not expect many changes or major changes in the scope later on. So it is a relatively static kind of scope, so it can be done easily. But if you have a large project or the project which has some uncertainty, there are some major changes required in any other phase, in the later phases, then it will become very difficult to manage, because we discussed that it means you have to go back to the requirement phase. If the scope changes, you have to go back to requirement, you have to fix it, you have to redo the design, redo the coding and testing phase. So this is a major disadvantage of waterfall approach. Project management triangle is a good technique to show the constraints in maintaining a good quality of any information system project. Quality depends on three factors: the available time, the scope of the system, and the cost or the budget of the system. So any change in one of this dimension has a direct impact on the other two. For example, if you increase the scope, okay, if the scope comes here, okay, then it has a direct impact on cost and time. An increased scope means you need more time to complete the project and you need to add more resources to the project. Similarly, if you have less time available to complete the project, then either you have to reduce the scope or you have to increase the cost of the project, right? So uh, any change in one of these factors, these three factors, has a direct impact on the other two factors. In traditional waterfall projects, these problems usually arise the first time the project is handed over to the testing team. Before that, the development team, they may be able to cover up their problem. But when the testing team takes this code, tries to execute the test cases, and now they find that there are many problems, the quality of the system is very poor. Another challenge usually arises in the test phase of our project. If more problems are found than the expected and the test cannot close on time, you cannot close the test in time, so the project cannot be delivered in the specified schedule. Now the options, what are the options? If the test cannot close in time, the options the leadership team has in this situation are very limited. What are the options? Let's see. As all functions are implemented, even reducing scope is difficult. Now you are limited by time, right? Now there are two other dimensions: scope and the cost. So if you are limited by time, let's say the first choice is reducing the scope. But even reducing the scope is not easy, because removing functionality usually adds extra effort. All of you know about coding. You have written some code, I'm sure. You have written some code in small or medium-sized projects. And you know very well that if I asked you to remove some functionality from any code, it is a tedious job, it needs effort. The code is tightly integrated together. There are many method calls in many places. Many methods, modules, functions, they are tightly connected together. So if I ask you to remove any functionality, you have to go back and uh, spend more time to remove those functions. So reducing the scope, again, it needs more effort. It will not reduce your effort, it will need more effort from you. The second choice you may think of is the cost. Now you are limited by time. You may think that we can add more resources. How we can add more resources? We are limited by time. So let's hire more people to complete the project in time, to remove all the errors, the bugs in the system. But again, there's a problem. So these resources, they need additional training, okay, from the existing team. So you hire, let's say, 5 more developers. Now the existing team members, they have to train these, and they have to tell them how the project was analyzed, designed, and developed. So again, it is counterproductive. You add more resources to reduce the time, but it takes more time. So ultimately, the leadership has only two options. First, extending the project until all problems are resolved and the required quality is achieved. So you just need more time so that all the problems, all the bugs are removed and the software has a high quality. Or sacrificing the quality of the deliverable. It is a very common problem. Many companies, they are notorious for this thing, that they will deliver an uncooked or semi-cooked product which has many bugs in it, and then they will keep issuing updates and fixes to patch up the problems in the software. So it has a bad impact on the repute of the company, right? So these are the main problems in waterfall development approach. There are two modified versions of waterfall approach which try to fix these problems. Let's talk about them. First, milestone and regular integration. One simple step to reduce the risk compared to traditional waterfall approach is to split the implementation, or you can say coding phase, into multiple smaller phases with integration points called milestones. This way, there are regular integration points with working code which can be used to check the project against the plan, and the test teams could even start to test the features delivered in those milestones. So the idea is that we are done with the requirements, we are done with the design, and now in the coding phase, we divide it into many milestones. So every milestone is scheduled both time-wise and content-wise. So first milestone will deliver some requirements, some use cases, and it will be scheduled, let's say, for 2 months or 1 month. Milestone 2, again, it will take, let's say, 1 month, and it will deliver another set of use cases, and so on and so forth. So every milestone delivers something. This milestone is handed over to the testing team. They test it against the requirements, and now if the problems are found, they can be fixed relatively easier. So every milestone will deliver something, and it can be tested in every milestone. At these milestones, the working system can also be used for presentation to the stakeholder to show the progress and request feedback. So we can also show these working systems to the users and owners, and we can get their feedback so that it can be incorporated. The important part is that these milestones should be planned, as I discussed before, that they are planned both date-wise and content-wise, right? So which use cases will be delivered and when they will be delivered. Another modified version of waterfall development approach is called incremental development. The idea of incremental development is that it, it breaks down not only the coding phase, the construction phase or implementation phase, but it takes the whole development process and repeats it several times. So let me show you how it works. So we take some set of requirements, we do the design, implementation, testing, and then we take another set of requirement, design, implementation, testing. So every iteration takes some requirements, develops design, constructs it and tests it. So now we broke down one waterfall into several waterfalls till the entire system is developed and handed over to the support team. So now it is possible to show working code much earlier to the stakeholder and customer, and we can get their feedback, and we can also incorporate it in the next iterations, right? So this was all about the traditional or the waterfall development approach. But as we said before, that waterfall development approach is not suitable for large projects in the industry. So in the industrial projects, mostly nowadays we use agile software development approaches, right? So let's see what are agile development approaches. Agile thinking is an attempt to simplify the things. The main philosophy behind agile development approach is to simplify the development process. How? By reducing complexity of planning. We do not focus too much on planning, but we focus on customer value. We focus on what is delivered to the customers, right? So in waterfall development approach, we gather complete set of requirements in the first phase, and now we plan everything. We assume that these requirements are not going to change, and we will develop a complete design and then complete construction, testing, and so on and so forth. Here in agile development approaches, we simplify the planning process. We focus on small iterations and we focus on customer value. Every iteration should deliver something to the users. There are many approaches which are called agile, like lean software development approach, Scrum, test-driven development, extreme programming, rational unified process, agile unified process, and in fact there are many other approaches as well. But today, because of a lack of time, we'll discuss only two approaches briefly. We'll talk about Scrum and we'll talk about extreme programming. These are the most commonly used approaches in the software industry. The basic philosophy in all the development approaches remains the same: to simplify the development process, to focus on the customer value, and quick and error-free delivery of the product to the users. Let's talk about Scrum first. The concept behind Scrum is drastic simplification of project management. It comprises 3 roles, 3 documents, and 3 meetings. Well, if you recall in SAD 1 and SAD 2, we talk about a lot of stakeholders which are involved. We have system analysts, we have designers, we have database designer, we have coders, development team, testing team, right? Project manager. There are so many roles. But here we have only 3 roles. Also in waterfall approach, we have lots and lots of documents. Here we have only 3 kind of documents, and we have only 3 kind of meetings. 3 roles are product owner, team, and Scrum Master. 3 documents are product backlog, sprint backlog, and sprint results. And three kind of meetings are planning meeting, daily scrum meeting, and the sprint review meeting. Let's talk about roles. Product owner, team, and scrum master. Product owner is the owner of the product. So he or she represents the stakeholders such as customers or the marketing department if it is a commercial software. And he or she will ensure that he represents the interests of all the stakeholders, the owner and user community, and he or she will also provide all the requirement, fund the project, and sign off on all the deliverables. Team, here we have only one team which is called team, and their job goes through the entire development process from planning, from requirement gathering up to the testing phase. Scrum Master is like a project manager. He is responsible for the entire Scrum process and for adjusting the Scrum process to best fit to the project and the organization. And he also ensures that all the issues and problems are resolved and that the team can be as effective as possible. So you can think of this guy as the project manager or team lead. Three documents: product backlog, sprint backlog, and sprint result. Product backlog, all the requirements are gathered and prioritized. Before the start of the project, all the requirements are gathered and with the priorities they are put in a document which is called product backlog. Sprint backlog, as is the case in all agile development techniques, the development is done in small iterations which are called sprints. So these iterations are called sprints in this methodology. Each sprint is a small and manageable iteration. It contains design, development, testing, and documentation. And the duration of every sprint is very short, let's say about 2 weeks. So at the beginning of a sprint, the team picks the most important use cases that can be delivered in that current iteration, and the list of those use cases is referred to as sprint backlog. So every 2 weeks time, we take some requirements from product backlog and put them into sprint backlog. This is the second kind of document. Sprint backlog means the set of requirements or use cases to be developed in the current iteration. And the sprint result, at the end of every scrum, we deliver the result. So this document is referred to as sprint results, the requirements or the use cases that have been implemented in the current iteration. 3 meetings: planning meeting, the daily scrum meeting, and sprint review meeting. Planning meeting, each new sprint starts with a planning meeting. So every 2 weeks we start a new sprint, and every sprint will start with a planning meeting. So this meeting has two parts. The team, the product owner, and the scrum master decide on the sprint backlog. So the team, the product owner, and the scrum master, they will decide on the use cases that should be delivered in the current iteration or the sprint backlog. Based on the requirements prioritized by the product owner, so the product owner has given the priorities for all the requirements. So those use cases which have the highest priority and have not been implemented yet, they will be put in the sprint backlog, and the estimates the team has done, right? So the team has also done some estimates for all the use cases, how much time is required to implement them. So based on these two criteria, sprint backlog is agreed upon. So as I said before, this meeting has two parts. In the morning, the product owner presents the most important requirements from the from the product backlog to the team, and at the end of the morning, the team selects those items that are going to be delivered in that sprint. So in the morning, they will agree on what use cases have been selected for the current sprint or current iteration. And the second part, in the afternoon, the team will develop a detailed plan for the current iteration. So every sprint starts with planning meeting, right? Daily Scrum meeting, as the name implies, this meeting is done daily and usually it is very short, let's say 15 to 20 minutes meeting, and the stakeholders in this meeting are the Scrum Master and the team, right? And they will discuss what has been achieved in the last 24 hours and what problems they encountered. So it is just to make sure that they are right on track and to identify any issues or any adjustments that are to be made in the sprint backlog. So the Scrum Master will meet the team every day to check the progress and to identify and resolve any issues. Sprint review meeting, it is at the end of every sprint, at the end of the sprint, 2 weeks time. Now all the stakeholders will meet again, Scrum Master, team and the product owner, to review the results achieved during the iteration. This is sprint review meeting, right? So let's quickly go through the entire process. So first of all, the product owner has a vision, okay? He has a vision and he will put all the requirements in the product backlog, okay? So these are all the requirements with the priorities of those requirements as well. So every sprint takes like 2 weeks time. It starts with a sprint planning meeting in which we take the most important use cases from product backlog and put them in the sprint backlog. These are the use cases that will be implemented in the current sprint. We have a daily meeting between the Scrum Master and team, 24-hour inspection, and at the end of 2 weeks, the sprint result document is generated, which is the use cases that have been implemented in the current iteration, and we have a sprint review meeting between all the stakeholders. So this process will keep repeating. Now we'll start another sprint. We will keep repeating the sprints till all the products have been implemented from the product backlog to the sprint result, right? So let's have a quick comparison between Scrum and Waterfall approach. This is a major difference to traditional Waterfall project, which elaborates plans and milestones to a much larger extent. This aspect of Waterfall approach makes changes of finalized plan quite inflexible and expensive, especially late in the cycle. As we discussed before, that in Waterfall development approach, we focus too much on planning. In Scrum, the project management as well as the product owner and other stakeholders accept this change as a fundamental planning constraint and try not to waste effort in planning beyond the horizon of the current sprint, right? So in the Scrum approach, we take it as a basic constraint that we cannot make a complete plan. So just focus on the current sprint. There are too many uncertainties. We should not focus on long-term plan. All the agile development approaches, just like the Scrum also, they break large project into iterations and really only worry about the content of the current iteration. And it gives the development team and the other stakeholders, the owners also, to make fact-based decisions for immediate needs. And it allows to even change the fundamental direction of the overarching direction at the beginning of every new sprint. So at the beginning of every sprint, you can even change the entire direction of the project, right? And any unforeseen issues you see in the current iteration, they can always be incorporated, they can always be addressed in the next iteration, right? So this is actually the philosophy of all agile development techniques. Keep it simple, focus on the current iteration, and deliver something to the user in every iteration. The second technique we discussed today is called extreme programming. There are 12 concepts behind the extreme programming, and we'll discuss all of them very briefly, inshallah. The first concept is test-driven development. If you recall, we discussed in the waterfall development approach that one of the main issues in waterfall development approach is that when the project is given to the testing team, they try to perform some functionality, they try to test the system, and now that tests, the system fails the test. So now you go back to the previous phases to fix those issues, and the cost of this whole process is huge. So the idea in all agile development approaches and in the extreme programming also is to automate all the test cases, right? And it should improve the productivity in the software development project. Test-driven development is a development method to ensure that developer also focuses on the development of test cases. So in waterfall approach, we have different development team and we have a separate testing team. Here, the developer focuses on the testing as well. It is his or her responsibility to write a code and test it to make sure that the code written by him or her, it passes all the test cases. The developer starts with the design of the additional functionality to be implemented. So the developer in every iteration, he will start with the design of the use cases. As soon as the design is done, the test case is written before the functionality itself is implemented. This is the main philosophy behind test-driven development. That after the design, we do not go into the coding phase, but we develop the test cases. So the developer, right from the design phase, starts thinking about the success of those use cases. So he focuses on test cases, he writes the test cases by himself. So now while implementing the test case, the developer validates the design with respect to what the function needs to provide and how it needs to behave. So now the developer has a clear idea of what is expected from this piece of code. So he'll make sure that it does not break, it does not fail the test. A test case should only be relatively small increment that can be developed and tested in a matter of hours. So all the agile development approaches are incremental. So these test cases are also incremental, and we try to make sure that they are not huge test cases which will take days to execute, but they should be able to execute in a few hours or so. The second concept in the extreme programming is pair programming. Well, the idea of pair programming is that two developers, they work at a team and they sit on the same desk, they work on one machine, one computer. So, first, let's say we have two programmers, A and B, okay? We have two programmers, A and B. So first, A is writing the code and B is just observing him or her. After some time, let's say 1 or 2 hours, now B starts writing the code and A is observing his code, right? So this is called pair programming. One writes the code and other observes the code, okay? So it requires some practice to become really effective. So in the beginning, it may seem a little bit strange to the developers, but with time, they get used to it. The studies have shown that at the end, roughly the same amount of code is produced, but because someone is looking at your code at the time of writing the code, so more errors are removed in the coding phase, right? Yeah. So this is a concept in extreme programming. It is called pair programming. The next is refactoring. Refactoring is improving the code without changing the outside behavior of the component. The idea of refactoring is that the functionality of the code remains the same, but the developer will try to improve the internal quality of the code. For example, the developer can remove any dead code, the developer can simplify the flow of the code, or can add more comments to make the code more readable, and it should help in the maintenance tasks, right? So the idea is that the functionality of the code remains the same, but you try to improve the internal quality of the code by simplifying it, by documenting it properly, or by removing any dead code in the system. After each step, the automated test suite should be executed. So we have to do the testing thoroughly. Whatever changes a developer makes, all the test cases are executed to make sure that the changes do not harm, do not cause any harm. The entire code is still working fine. The small steps should ensure that mistakes are identified earlier and can quickly be fixed. Next, simplicity, as we discussed before, that all agile development techniques, they focus on simplicity, they focus only on the functionality needed, and not the future planning, the future aspects, or the things that are beyond our control. So try to keep the focus on the current iteration, try to keep the planning as minimal as possible, and do not focus in the long-term planning, in the uncertain things. So simplicity is the philosophy behind all agile development approach. And the same concept, planning is also related to simplicity. So in the extreme programming, every iteration is done in a very short period, like 2 weeks time. So we do not focus on long-term plan, we just focus on the current iteration, what can be delivered, and what is most useful for the users. Small release, it's also the same thing, that every iteration should deliver something customer ready. The idea is that every iteration should give something to the user. They should get benefit from every iteration. So the iterations are planned in such a way that in an extreme case, even if the customer stops the entire project at any iteration, they should still end up with something. Just imagine waterfall development approach. Let's say a waterfall development approach uh, starts from the requirement phase, and let's say it is a 5-year project. You do all the requirements, all the design in, let's say, 2 years time, and in third year when you are doing the coding phase, let's say the project is stopped. What do the customers get? Nothing. Customers get nothing. Here, in case of agile development approaches, the iterations are planned in such a way that even in any iteration, if the project is completely stopped, the users should get something, right? So it is very important that the use cases they selected for the current iteration, they need to be 100% completed in that iteration, because if they are not completed, then the customer do not get anything useful, because they are planned in such a way that every iteration gives something to the user. So every iteration should be completely done. An additional benefit is that you can quickly show something, experience immediate success, and can better estimate where the project is time-wise. So you have a sense of achievement, and you also have a sense of measurement. Where do you stand in respect to with respect to the time, right? Continuous integration. So every release will also have some integration. For after every release, the complete product build is done. So it should happen every day and should be followed by the complete testing to make sure that all the code is working fine, right? So we have a continuous integration of any newly written code in the existing code, and we keep testing it like every day to make sure that the code is of good quality. Continuous testing, again the same thing, that continuous testing ensures that the code is really doing what it is supposed to do and confirms that none of the existing functionality broke with the latest changes. As we discussed before, that every iteration, every integration should also do testing to make sure that new functionality does not affect the old functionality. An extensive set of automated test cases is needed that the developer can run during unit testing, and then it is also executed against the product builds. Let's say the daily, at least daily product builds, to make sure that the project is going fine. As soon as the developer changes the code, the test cases must be adjusted or new ones written to cover the additional functionality. Whenever the developer writes new code, now we need to make adjustments in the existing test cases, or we need to write new test cases so that the incremental testing can be executed. Next thing is the code ownership. Now, ownership means that all developers know the entire code, and all developers, they should be able to work on all parts of the project, right? So let's say there's a team of 5 members. So each one of these 5 members should have a clear idea of the code written by all the other 4 members, right? So all 5 members should have a clear understanding of the entire code written by this team. Why this is required? Because this way the better quality of code is achieved. Because if the code is being reviewed by all the other team members, then they can identify the mistake, they can fix those errors, and ultimately the quality of code will be better. And another benefit is that if we have an emergency situation, there are more people who are available. Let's say the project has been delivered, and now suddenly there is a new bug discovered. So now we have more people who are available to fix that bug, and because all of them, they have knowledge of the code. So let's say if only one person knows about the code, if let's say we have emergency situation and this guy is not available, he is sick, he is on leave, or he is not available, then there's nobody to take care of the code. So in this way, more people can help in the emergency situations. Of course, there's a limit to collective code ownership. As soon as the project team becomes larger, let's say more than 10 to 12 developers, then we can break it down into smaller teams, and each team will take responsibility or ownership of some part of the code. The next thing is the coding guidelines. Every project follows certain coding standards and guidelines, because if you follow coding guidelines, the code is more readable, the code is more understandable. So if someone has to maintain the code, if there is a bug, you need to identify the bug and fix it, and the code has poor readability, it will take more time to fix the bug. So every project follows certain guidelines or certain standard, and it is very important to make sure that coding guidelines are followed. Just to give you some idea, like naming of the variables or classes or methods is one thing in a project. I'm sure you know about camel case, right? I'm sure you have discussed in any programming course the technique called camel case. Okay, sorry. Camel case is used to as a naming convention in which the first letter of every word is capitalized, right? So it is one technique. Or you can use underscores to separate different words in the names of variables or classes or methods. Similarly, module size is another coding guideline which is used. The nesting of the blocks, like nested ifs, if blocks. So there are many things that are used to make sure that the code is more readable, it follows guidelines, it is documented properly, and the maintenance of the code is easier. The last guideline is on-site customer. The idea is that the project team always needs to keep in close contact with the customer. The project team should be in close contact with the customer to get the requirement, to know their expectations, and to discuss any changes which are required. So we call it end-to-end development. So the developer is in direct contact with the customer. They take the requirements from them, and when the system passes the test, it is delivered to the customers to get their feedback. So this way we can ensure that the customers' expectations are met more properly, and we end up with a better system. Instead of, let's say, we develop the entire project and then it is handed over to the customers, and then they say, oh no, this is not what we mean, this is different from what we expected. So now if we have to go back to fix all the requirements, design and code, it will be much more time consuming task, and this is one of the main issues in the waterfall development approach. So on-site customers mean that the developer or the entire development team is always in direct contact with the customers to make sure that they know what customers want in the project. That's all. We have discussed the waterfall development approach, and we also discussed two of the agile development techniques today, Scrum and extreme programming. So that's the end of lecture. See you inshallah in the next week with the last lecture of the course inshallah.